Hi, welcome back to Max Learning Groups. Now, today we are going to look at this question, right? A school exam paper question from I think it's from Raffles Girl. Yeah, Raffles Girls 2019 SA1. This is a question that is actually not very difficult because you only have one mixed topic or one topic in this problem. You look at this question, you can see that they are entirely fractions, all fractions. So questions that have mixed topic like percentage, there's ratio, there's also fraction in the same problem, and then that question will be, of course, will be a little more complicated. But this question, which is only one topic, there's only one topic inside, so it's actually not that hard, right? Because there's only one topic. So the only problem is, right, the only problem that the students may face is whether they are able to draw the model, right? Because when there are fractions in the problem, then the method that we can use is model drawing, right? Is always model drawing when you see fractions. So the question is whether can they draw the model, and usually not many can draw the model, right? Because you need to practice drawing the model, and then you will achieve a certain level of mastery, and then you will be able to draw this problem. But there are some students who can draw out the problem, right? I do see students who can draw the problem, and that's fantastic. But otherwise, most students, when they draw the model, is really very basic. When you look at your model drawing, it's like primary 4 drawing or even primary 3 drawing. So there's nothing about the drawing that can help them to solve. How do you know whether a model is good? Now, a model is good when you can look at the model on its own without even looking at the question, and that is a good model because the model brings out the whole problem, and by looking at the model you can solve already. But if I look at your model and I still can't solve, then your model has something missing or not complete. So you will need to add on to your model. Okay, so I'm gonna use a different method because to help those students who are not able to draw model. So if you cannot draw model, then what do? Then you're going to change your method, right? You're going to change your method to something called the table method. And this table method, which I mentioned before, it is not really taught in schools, right? Because school teachers, they usually use model drawing, or they'll be doing something else. Okay, but this table method is not really practiced. I don't really see a lot of schools practicing on this table. Some schools, they do that. Some teachers, it all depends on your school teacher, whether they understand this method and they are using this method to teach a class. And some school teachers, they may not see this method before, and therefore they don't teach the method. So it's not really standardized across the board. All right, some schools, some teachers, they do this, some they don't, some don't. So I'm going to show you this method, the table method, which you have seen already. All right, and it's actually very easy. All right, the table method is easy. It's like model drawing. No need to think, no need to think about how to solve. You just have to put numbers in the table, and then later on, a good table is something that you don't have to look at the problem. So what is a good table? No need to look at the question, and you can still solve. All right, so let's read the question. Mrs. Tan baked some muffins. 3/5 of the muffins were banana muffins, and the rest were walnut muffins. So her family ate 3/4 of the banana muffins, and she donated 252 walnut muffins to an old folks' home. Then she had 1/4 of the muffins left. Okay, so what fraction of the muffins did her family eat, and how many muffins did she bake altogether? Alright, now if you remember the earlier lesson, when you tackle a problem in the exam, there are some general questions that you have to ask. Number one, is it a story sum? If it's a story sum, then you need to ask a question. Is it a before and after problem? If it's a before and after problem, then you need to ask another question, which is what is unchanged. So in this question, what is unchanged? Then you have 4 answers, right? Total unchanged, difference unchanged, one group unchanged, everything changes. So in this question, everything changes, right? Okay, so once you have all this in mind, and it's a before and after problem, then you choose your method, table or model. So let's use table. And table is a big lesson, right? It's the biggest method is model method, and the second biggest method to learn is actually the table method, because this table method can be used to solve all the before and after problems, even those questions with 2 changes or even 3 changes. Like what do you mean by 2 changes and 3 changes? I'm sure you have seen some questions where you see something like you have 3 pails, pail A, pail B, and pail C, and you take out some water from pail A and pour into pail B, and then you take out some water from pail B and pour into pail C, and then later you take the water, some water from pail C and pour back into pail A, and then all the 3 pails have equal amounts of water. So that kind of question has 3 changes, and is totally impossible to draw the model, right? So that's when we have the table method for these 3 changes, right? This before and after problem that has 3 changes. So this is a second biggest method, means there are quite a number of lessons to learn about this table method. So how do we solve this problem using the table method? So you have your labels. Okay, you always start with rows and columns, and you have to recognize whether is it 1 change or 2 changes or even 3 changes, and then you have to put your labels. So your labels will be your banana muffins and the walnut and the total. Okay, alright. Now, something similar to model drawing. You always start from the beginning to the end. So Mrs. Tan baked some muffins, there's nothing to put inside. 3/5 of the muffins were banana muffins. You can break up the fraction. So the muffin, altogether the muffin has 5 units, and 3 units were banana muffins. Therefore, there must be 2 units of walnut muffins, right? So you have filled in the boxes until the second sentence. Now her family ate 3/4. So her family ate 3/4 of the banana muffins. So there is a minus 3/4. So you can put the fraction into the box, and then there must be 4/4 at first, and then the fraction of banana muffins in the end must be 1/4 left. So there must be 1/4 of the banana muffins left. And she donated 252 muffins to an old folks home. So you minus 252. Okay, alright. So you are done until here already. Okay, then she had 1/4 of the muffins left. Alright, 1/4 of the muffins left. That's another fraction. So what do? Okay, so that is the total, that is the muffins left, total muffins left, which is 1/4. 1/4 of the muffins left. Now I use a different color because you can see there are 2 1/4s, but they are different, they refer to different things. Okay, different number, different kinds of things. That's why you have 2 different colors. So if there's 1/4 of the muffins left, then there must be 4/4 of muffins at first, and you must have what? You must have eaten and given away 3/4 of all the muffins, right? That's why you get 1/4 of the muffins left. Okay, and your table is done. Yeah, that's our table already. And of course, there are some blank boxes you can see. So what fraction of the muffins did her family eat? So if you can't put the question mark in the boxes, then you don't put inside. How many muffins did she bake all together? So your question mark will be the total at first, and that is your question mark. Okay, see, until now you can see that I'm not thinking, right? I'm not really thinking about how to solve. Just put numbers into the right boxes. Now, what is a good model? What is a good table? A good model and a good table is when you don't need to look at the question. Okay, if you have to look at the question to try to solve, then your table is missing something or your model is missing something. So that's how you gauge. That's how you gauge whether your model is good or not so good, right? So when you draw your model, are you able to look at your model and then get the answer out of the model? That's a good model already. Okay, so let's look at the table and how do we find the question mark? Okay, if you look at the boxes, you can see that 4/4 is in the same box as 3 unit, or they are equal to each other. So 4/4 is 3 unit. So 1/4 must be 3 unit divided by 4. That will give you 0.75 unit. Okay, so whatever you found, you put into your boxes. So which means that this is 0.75 units of banana muffins left. So how many banana muffins were eaten? So you times 3. So 0.75 and you times 3, that will be 2.25 units. Okay, so which means that you have eaten how many banana muffins? So you have so the family must have eaten 3/4, which is how many units? Minus 2.25 units. Okay, so make sure your boxes are big, right? Big enough to put the numbers inside. And of course, no need to look at the 4/4. I can throw away the 4/4, 3/4, and the 1/4 because I have the units already. Okay, and then what else can I do? Alright, if you look carefully, you look at the green color, you can see that 4/4 is in the same box as 5 unit. Same box. Then your 1/4 will be 5 divided by 4. And you will get 1.25 unit. Okay, so it's quite simple. So which means that 3/4 must be how many unit? So 1.25 times 3. That will give you 3.75 units. Okay, so how many muffins in total were eaten and donated together? So you must have eaten and donated altogether 3.75 units of muffins. And that will give you how many muffins left, which is 1.25 units of muffins left. Okay, so we are filling up the boxes. And then can you fill in the missing boxes? Can you find how many walnut muffins left? Yes, I can. I take the total muffins left minus the banana muffins left. So 1.25 and I minus 0.75, I get 0.5 units of walnut muffins left over. Okay, so now can I find how many walnut muffins were eaten? So I take 2 units at first. Okay, maybe I should write down. Okay, write down. So 2 units of walnut muffin at first, and now you have 0.5 units of walnut muffins in the end. So you must have donated how many walnut muffins? You must have donated 1.5 unit of walnut muffins. 1.5 unit, and 1.5 unit is in the same box as 252. So your 1 unit will be 252 and divided by 1.5. And your 1 unit is 168. So the purpose of model drawing table method is to get your 1 unit. To find 1 unit is how many, and then use that to get the question mark, which is to find the total. Right? How many muffins did she bake altogether? Which is 5 unit. So 168 times 5, and she must have baked a total of 840 muffins altogether. And we did part B, right? And then how about part A? So what fraction of the muffins did the family eat? So what fraction of all the muffins, which must be at first, right? All the muffins at first, did the family eat? So the total is 840. All the muffins is 840. And the family has eaten how many? The family has eaten 3/4 of the what? Of the 3/4 of the banana muffins. So 3/4 is 2.25 unit, right? 3/4. So the family has eaten 3/4, which is 2.25 unit. And how many is 2.25 unit? So you go back to 1 unit, which is 168 times 2.25. So the family must have eaten 378 banana muffins, and you put that into your fraction. Alright, and if it's a paper 2, please don't divide by 2, divide by 2. You can actually take your calculator and just key in 378 out of 840 and then press equal. And that must be 9/20. So the family must have eaten 9/20 of the muffins. And your answer is part 9/20 for part A. Okay? And that's how you solve using the table method. So you can see that this method is very effective, very useful, right? And but it's a big lesson, right? It's not like assumption or guess and check where one lesson can teach you the method already. But this method will take a few lessons, right? A few lessons to cover, because this method can solve all kinds of before and after problems, whether there's percentage, whether there's fraction, whether there's ratio. You can actually put them into a table, right? So that's how you use a method to solve. So if you can't draw the model, then what is your backup? Your backup is the table method. But otherwise, then if you can't do the table, then hopefully you can draw the model. And if you can't do both, okay, if you can't do both, then you will have to really tap on your brain to try to solve it. Of course, that's when it gets very hard to try to do on your own already. Okay, but otherwise, try to learn how to draw the model. And how do you draw the model? How do you excel in model drawing? You have to keep drawing, as long as the problem allows you to draw, right? Because there are some questions you can't draw, then you don't draw. But if there's a question, any questions that you think can draw the model, you should not avoid model drawing, but you should go and try to draw the problem. Right? And then the more you draw, and then you'll be able to draw out more difficult problems. And at the same time, you may also want to know this method, right? Learn how to use this method. And once you can use this method, you have a backup as well. So you have 2 choices to solve the problem. Okay, so we come to the end of this lesson. So stay tuned to the next school exam question. So it'll be quite interesting, right? I will show you how to solve problems. So it'll be quite fun. All right, math is actually very, it's not hard to do well. All right, it's actually quite easy to do well. like science, okay, you just need to know your heuristics, right? Your science heuristics, your math heuristics. Once you know all these heuristics, then the rest are easy. You just have to apply the heuristics onto your solving. Okay, so see you in the next lesson.